Good day, ladies and gentlemen, and you're all very welcome to this Saturday's technical session of the CNPS. Now, it's been some weeks since we've had a full technical session, and we actually have missed a number of weeks. Unfortunately, the schedule has become a bit uncertain. But the good news is that we have two more talks scheduled for August, which I think will be of great interest to many of our participants. So do keep an eye on that, and thereafter we'll be looking at maybe continuity of these technical presentations. But I'm delighted to. So today is the 18th of July 2026. Obviously, I'm Ian Cowan. So we're continuing as we have had, and in fact, I'm delighted to say that we have Jim Marsen back again. He spoke to us. Actually, we'll be having another talk in August by him, I'm hoping. But anyway, that's on another subject. Jim spoke to us on the 23rd of May last on this Brillet-Hall experiment of 1979. And he was addressing the question as to whether it really did detect the ether. There were some strange signals, maybe a spurious signal, which they seem to dismiss, which has been analysed later to be consistent with maybe looking at the orbital rotation of the Earth, not the revolution around the sun, but the daily rotation. So, but actually, there were some comments that I hope that talk and the recording, you might like to look at that if you haven't seen it, but still will be of interest to many people. But I think a valid criticism was made that if one was not totally conversant with the details of the Brillet-Hall experiment, one might have been a bit at sea. And maybe towards the end of the talk, it was Jim and myself just talking one-to-one, because we're both sort of specialists in this area. I think we've both looked at this in great detail. So what I've tried to do is I've tried to discuss this with Jim and get him to come back, which he's very kindly agreed to. And he's going, I think, to spend a little time at the beginning just giving you maybe a bit of the bones of the experiment. And then he'll be talking about his proposals to repeat it with equipment, modern equipment, because actually this experiment now is nearly 50 years old. So, but just if I may just say one or two words myself before handing it over to Jim. The Michelson-Morley type experiment, which most people are familiar with, trying to detect the motion of the Earth, if any, through an ether, let's say, by seeing how the speed of light would vary depending upon whether you're moving with, against it, or at right angles, or indeed at any other angle. That experiment has been performed many times between the 1880s and the 1930s. And there's a lot of controversy about it, whether the experimental errors were so great or there were other effects. For example, the Miller experiments of the late 1920s seemed to indicate a positive effect, but then people said, oh, the instrument was affected by temperature effects and so on. So a number of people, including myself, if I may say, have looked at, and Jim, if I may speak to him for him a little, have looked at this and said, well, look, there is a model which seems to be consistent with both theory and also practice, that if there is a sort of an ether medium which can conduct electromagnetic radiation, well, the Earth in its daily spin actually will move through this without any drag. But in the Earth's orbit around the sun, it actually carries that. Well, that would explain the Michelson-Morley experiment. In fact, that is one of the early things that was drawn to my attention, about 30 years ago, which got me into this whole area. I said, goodness me, I was never told that at college. But it's such an obvious proposal. But anyway, so if there's something in that proposal, the first experiment, which perhaps was almost on the borderline of having enough accuracy to be able to determine a velocity difference of the order of hundreds of meters per second, which is what we're talking about when we're talking about the spin of the Earth, rather than, say, tens of thousands of meters per second, which is what we're talking about when we're talking about the rotation. The first experiment was possibly one performed by 4 people, Jasova, Javan, Murray, and Towns in 1963, and it was using maser resonant cavities. So you have a sort of a nettle-on, and it's a cavity, and you're looking at the propagation frequencies. You have mirrors at either end of the DC discharge between the electrodes, and you're looking at that. So that perhaps was on the borderline. It might not have had a sufficient accuracy to give maybe whatever it is, 400 meters per second or something. But it seemed to give some results. However, in 1979, and this is what Jim is going to be talking about today, it certainly had sufficient accuracy. It was 4,000 times more accurate than the 1963 experiment. And Brillet and Hall, working in Colorado, I think Brillet was a Frenchman. He was perhaps on secondment, and they were Hall was in Colorado. They did this experiment, and Jim will be talking about this now. They were using lasers, by the way, light amplification, and again the official result was sort of practically zero. But there was this spurious signal, which has been analyzed later to be consistent with the speed of the Earth's rotation at Colorado, which is quite strange. So if that's true, they dismissed as spurious a signal, which actually was not spurious, quite the contrary. So I hope I haven't bored you too much by giving my own take on it, but I hope that's helped. Now, I'm going to go over to our main speaker. So Jim, you're very, very welcome. Thanks for coming back at such short notice and within 2 months period to address this shortfall.
I have a beard now, see.
Yeah, that's right. I thought I said it's another bearded man. Yes. So we're all getting wise in our old age.
Yeah.
So what we'll do, with your permission, is I'm going to hand over the floor to you. You know the ropes. I don't have to explain it to you, so it's quite easy because you spoke to us many times before. And the floor is yours. You can share your screen. You can tell me what to do. I'll disappear. I'll be there in the background if you need me. I'll be keeping an eye on the questions, which you can as well, but I wouldn't worry too much about that. Leave that up to me, and I'll refer anything to you if necessary. If it's really urgent, I might interrupt, but I'll try to avoid that. And then at the very end, we'll have, maybe it's 50-50 roughly talk and discussion. We'll have a discussion, and people in the green room can come in and quiz you and me and so on. So if that's all right, Jim, I'm going to go down now. And do you want to share your screen, by the way, now?
Yeah, I'm working on it.
Oh, you've done it. Sorry, you're ahead of me. Because I put it up. I do. So it's that. Is that correct?
Yeah.
That doesn't seem right. Oh, yeah, okay. You'll put up what you want. So I'm going to disappear. I'm going to maximize it, and it'll be all yours. And just call me if you need me.
Can you see the PowerPoint here?
I can. I'm going to maximize it now. Yes, it looks good.
Let me bump it up a little. No, it's too much.
Actually, I think our participants know that they can click at the bottom right of their own screens a little broken square, which will maximize the image for themselves. Unfortunately, I cannot do that because I need to keep an eye on the questions which are coming in. But people can increase this, for themselves.
Okay. So we're trying to investigate the possibility that this experiment back in 1979 might have actually detected the ether, but dismissed it, and why. So I don't know how far back I need to go in terms of explaining the Michelson-Morley experiment, but the idea was that in 1887, Michelson and Morley tried to measure the velocity of the Earth moving through what was assumed to be a universal ether. In other words, it was the same everywhere. So back then, they only knew that about the orbit of the Earth, 30,000 meters per second around the sun. So they assumed that they should be able to detect that motion with an interferometer. And they didn't. Although some people have tried to claim that maybe they did, but they said that it was below their ability to measure fringe shifts, because that's how they were trying to detect this this flow. And people kind of jumped to the conclusion that it was exactly zero. Not just that it was below the threshold of their sensitivity of their device, but that it was totally null. And then they tried to explain it. And the first person to try to come up with this explanation was Heinrich Lorentz, who said it was because the arms of the interferometer were contracting just enough to cancel the effect. And then Einstein came along and said, no, it's because space itself is contracting and time is dilating. And that explanation stuck. And it's stuck all through since then, essentially, in his 1905 paper. But some very few people have questioned whether it's really null to infinite precision, and not just less than the sensitivity of their instruments. And many people tried to improve the sensitivity of their instruments and do additional experiments, and still kept coming up with no detectable fringe shift. And they had to measure this fringe shift because it was an optical device with by looking through a microscope and looking for a change as they rotated their device, because they were as the device would sweep through what they considered to be the direction of this flow that they assumed was the sensitivity of their ability to detect a fringe shift, which is what they were looking for, was limited to less than a 40th of a fringe shift or so. But they still said null, and null to infinite precision, which is what Einstein's special relativity essentially assumes it should be. Rather than just saying, well, maybe our instrument isn't sensitive enough to detect a signal. But they still thought the signal should be at least 30,000 related to the Earth's orbital speed, because everyone assumed a universal homogeneous and isotropic ether if it existed. And that's how things have stood for 100 and 20 years now, I guess. So back in 1986, Peter Beckman wrote a book where he claimed that maybe it wasn't zero, and it wasn't due to the ether surrounding the Earth and rotating with the Earth, so that there would be no signal to measure. He said, well, maybe it's related to the gravitational field that the Earth generates, and maybe it doesn't rotate with the Earth. The Earth rotates through it. And if that were true, then the velocity of the lab or the interferometer with respect to this halo that surrounds the Earth but doesn't rotate with it is fixed in direction relative to the fixed stars, would be much, much smaller than the velocity that was assumed to be by this universal ether idea. Although the assumption of you have to admit that the assumption that of a universal homogeneous ether is just an assumption. There's no way to claim it, except that it seems logical, I guess. So anyway, instead of 30,000, according to this idea, instead of 30,000 meters per second, it's maybe only 355 meters per second, which is the Earth's, 465 coast latitude, essentially, which is the Earth's rotation rate relative to a fixed direction, like what's called the ECI. And that and also note that the actual velocity of the lab or the interferometer would vary with latitude. As you get up into a higher latitude, north or south, the relative speed of that lab with respect to a fixed direction in space decreases. That's just geometry. And so by the way, at the latitude where the Brillet-Hall experiment was conducted was about 40 degrees north, which would make this assumed speed around 355 or 360 off roughly meters per second. So that's the question. Were all the previous failed or Michael Zimorli type experiments, is at least a question in my mind anyway, and a few others, but not very many, was the failure to detect anything, the null results, really just due to their instruments weren't sensitive enough to detect this much lower velocity flow or wind or whatever you want to call it. And that's been my argument for several years now. So at one point I thought that the only way to, well, let's go back another step. So in the 70s and 80s, after satellites were more normally launched, and they eventually came up with the GPS system, where satellites transmit a pulse, which is picked up by your cell phone, essentially. And you can use the timing of those signals as to calculate your position, obviously, to, in some cases, centimeter accuracy. But they discovered, I don't know if anyone was expecting it, but that you have to compensate the signal. So here you have a satellite, and it transmits through what's assumed to be the ECI, the preferred frame, according to my theory, or Beckman's theory, or another physicist named Ching-Chuan Su. And your receiver is moving while the signal is being propagated to you. So the path length changes, and the time it takes to receive the signal changes. And that's a well-documented phenomenon that you have to compensate for when you're running your GPS fix algorithm on your phone. It's called the GPS SAGNAC correction, because it is, in effect, a SAGNAC effect, which I need to explain more clearly. Well, I mean, this kind of shows you, but if you think about any kind of classical wave in a medium, like a simple dropping a rock in a pond, and you've got a toy boat waiting to see the wave come, but the boat is moving away or toward the rock where the rock dropped. It's going to take longer or shorter for that wave to arrive due to the speed. That's essentially the SAGNAC effect, although it's been distorted by supporters of special relativity because of the way SAGNAC originally did the experiment, to say that it's actually a rotation effect, whereas here you can see it's not. It's just the movement or the change of the path length during the propagation process. So, long story short, this is considered to be a first order effect of wave propagation, in the sense that it's proportional to the velocity of the receiver with respect to the medium, divided by the speed of propagation in the medium. In this case, it would be the velocity of light. But it's not just that, because the first order effect has to do with where the receiver would be at the moment of emission of the wave from the transmitter, that's the first order effect. But while the wave is propagating to that spot, the receiver is still moving. And that's essentially a second order effect, because it's in other words, it takes even longer to get to the actual spot where the receiver will receive the wave. And that's what's called the second order effect, in that it's proportional to v squared over c squared. I think it's, and that's not disputed. That's a real part of any proper derivation of the Sagnac effect. That there's this, but for the GPS system, it's extremely small. It's only affects the calculation of propagation time to be less than a centimeter, maybe even a millimeter. I forget what the value is. So it's essentially ignored, and a lot of people ignore it anyway. And in fact, Einstein effectively said there is no second order, by claiming that the two-way speed of light is always the same, no matter how fast the receiver is moving. And that's the essence of special relativity. That assumption that there is no second order effect of essentially the Sagnac effect. And that's what I'm disputing, that there is a second order effect. It's just too small for any of the previous interferometer experiments before Brillet-Hall to detect. And as I've said several times already, people jump to the conclusion that it meant there is no second order effect. But if you do the calculation of what the second order effect would come out to, that's the value that Brillet-Hall supposedly detected and discarded as pure systematic, even though they couldn't explain what was causing it in terms of the tilt of the table or temperature, inhomogeneous factors, or they tried to eliminate all those possible reasons for it and couldn't find anything that could account for it. So here we're saying that the Sagnac effect essentially does predict exactly, or at least within a factor of 2 of what Brillet-Hall detected. And they were the first experiment using lasers and a very precise what's called a Fabry-Perot etalon to as a new way of doing a Michelson Morley type experiment, instead of having two mirrors on perpendicular arms and rotating that. This is essentially a much more precise, sensitive instrument. And instead of using an optical eye detector, they were able to essentially detect their fringe shifts electronically, which made them much more sensitive. They could detect a difference in frequency instead of a physical motion or shift of a fringe shift in their eyepiece. So now the question in my mind at least, is was the signal actually real? You know, there was an analysis by Professor Howard Hayden in 1990 that pointed all this out. So the one reason why they claim they had to declare this signal spurious and systematic, essentially, an instrument malfunction or noise source that it meant that it wasn't a real signal, was that they were assuming in their framework of how they analyze their data, what's called the RMS, or Robertson Mansouri Sexual test theory, which essentially meant that any signal that wasn't due to the Earth's orbit, or at the time, this was like 2 years after Professor Smoot declared that there was this CMB dipole that meant the Earth was moving with respect to the CMB at approximately 370,000 meters per second toward, I think it was, toward a fixed direction in space, essentially. I forget what the name of the constellation, but it, under that assumption that essentially that there is a universal ether that and that universal ether is defined by the CMB, essentially, and that the Earth is moving within that preferred reference frame, even though Einstein says there's no preferred reference frame. And that paper had been published in 1977, and I think Brillet-Hall even admitted that they were trying to test that CMB dipole velocity. So to do that, they adopted the RMS framework, which meant that they had to modify their so this is a diagram of what their data was showing them. It was clustered around, the raw data was clustered around a 17 hertz deviation, which transforms or is what you would calculate for the Earth's rotation velocity at that latitude. the raw data clustered around this in terms of the phase of the signal. And when I say phase, I mean so if this hypothesis that the preferred reference frame is actually the ECI, the Earth-centered inertial reference frame, which is what I was talking before, is the name of this idea that the Earth, the ether doesn't rotate with the Earth, or it doesn't flow through a universal ether. The preferred reference frame, the medium, the pond in the rock analogy, rock and pond analogy, is at rest with a fixed direction in space called the ECI. So not only is the velocity determined by geometry in the sense that it's a function of latitude and it's a function of the rotation speed of the Earth, but it also means that it's constant in direction. It's always due east, and it's always horizontal, exactly horizontal to the Earth's surface, or a circle around the radius of the Earth at the location where the lab is. Anyway, so this would be like scatter in terms of whether it was due east or not. So that could be due to noise, or but it was constant in some direction. But they didn't print and couldn't recover when they were asked what this direction was. I think if it was east, it'd be a lot more convincing. But it was, in their experiment at least, within this ballpark range, constant. Whereas when they analyzed their data and they presented their data, which essentially they declared was the most precise detection of a null result, delta C over C less than 10 to the minus 15th. They essentially took all these points, and each one had a different, we're taking a different time of day. So if you average over a day and assume that you need to point to a specific direction in the sky, they all average out to 0 or close to 0 within another noise band. And that's what they presented as their conclusion. Now, I'm going to ask Ian to come back in here and let me know if I explained things clearly enough.
Yes, thank you very much. Actually, I was just typing a note basically to David to Hilster. He just said, make the slides bigger. Actually, what I've had to do is just maximize my own screen to read the information, which is excellent. But I'm just wondering if, by the way, the thumbnails might be got rid of so you can make them a bit bigger. Anyway, that's incidental. Because they are a bit small, unless you maximize.
Yeah, I'm sorry. I'm not a great PowerPoint.
The slides are great, but
I
it's just
think I
a
have to publish it or something and then open that.
Yeah, you might. At the bottom right, are there not some little symbols? That's
yeah,
right, down there.
Yeah, but then
To have slideshow. So in other words, the very right one, that one there. Yeah, try that. See, that's a bit better. All right. Yeah.
Okay.
And what I'll do is when you're getting back, I'll get rid of our videos here. But yeah, I think you've been doing a good job. The other thing in the Brillet-Hall is they talk about getting this spurious signal, which you're probably coming to on the what do they call it, the second harmonic, when they're analyzing this by sort of Fourier analysis.
You mean a Fourier analysis?
Yeah, so they get this 17 hertz so-called spurious signal. Now, I think the analysis by people like Aspin and perhaps Hayden, whom you referred to, would be that you could do an analysis.
Possibly expecting twice the 17, maybe 30 hertz.
Yeah.
That was Hayden.
But I think his thing, he works it out, just by what the signal should be. And he gets, I've forgotten what it is, 0.131 V squared over C squared equals that value.
Right.
And from that he gets he recovers the 300 and whatever it is, 55 meters per second. So you're probably going to come to that, are you? You've been giving a good introduction, Jim.
What about James Keen? Is there?
Yeah. Okay. So James, let's see. I've been sending one or two comments or talking to James in the comments here, and he's been asking some interesting questions. But I said let's deal with those during the discussion. And he's very
I just wanted to see if there was something I didn't explain.
Well, if you wish,
explain more for him to understand what I'm trying to get at.
Quite so, yeah. Rather than just have my response, and it's perhaps said that I have some familiarity with the subject. Why don't we break for 5 or 10 minutes? Just ask, is that all right, from people? So what I'll do, with your permission, Jim, is I'll just ask anybody to pop in the comments any specific suggestions as to what you might do better, or if what you've done is satisfactory. And I'll ask a few people to come in on the green room just for 5 or 10 minutes to respond to your query. Is that all right? So in particular, Jim, I know you've been asking some questions, and we'll have a full discussion at the end. But do you think that Jim is moving in the right direction? Has he cleared up some of these questions that you and others may have had? Or would you like him to deal with any other specifically?
Well, he occasionally refers to the direction of fixed stars, or what we might call galactic coordinates. And it would seem to me that some interesting analysis might be whether these shifts that occur, whether they're smaller than expected or not, maybe the size of the shifts is not the most basic question here. Maybe it's, do they cluster with respect to the coordinate system of the fixed stars? In other words, a galactic coordinate system. And if they do, that would be some real evidence of fixed ether, wouldn't it?
Okay, well, this all goes back to what Cheng Chuan Su proposed in 2000, that the local ether around any celestial body is like a halo that is related to the gravitational potential distribution. So the Earth generates a gravitational potential around it, and then the sun does the same. And at some point, the sun's gravitational potential, as you get farther away from the Earth, dominates, and it becomes the preferred reference frame. We're saying that the preferred reference frame is essentially the dominant potential.
Well, no, I'm not saying
potential.
that actually. I'm saying that doesn't the idea of the ether imply a fixed reference frame? It's not preferred. It is the reference frame.
Well, that's the interpretation I'm challenging.
That's the universal ether as distinct from the local ether.
Is that what you mean?
Well, I'm just looking for evidence of a universal reference frame.
Well, I guess what I'm trying to say is that the GPS system depends on the Earth's ECI frame, the local ECI frame, as the preferred reference frame for EM, electromagnetic phenomena near the Earth, actually within probably at least out to the moon, and possibly out to L2 where the JWST
it seems to me
lives.
that there are multiple lines of evidence for a universal reference frame or ether, if you will. And I'll thank you for the presentation thus far. I look forward to where you're going with it next.
Well, thank you, and we'll certainly have you back, Jim, towards the end.
Okay.
Thank you very much. Jim number one, Jim number two, so call me James. Sorry, that's not the one I wanted to show. So Shockwave said, take the experiment off-world, put it in space. So I'm not quite sure. Perhaps you're about to come to this, Jim, but would you propose doing a very accurate modern experiment on the Earth, or would you think about doing one in space? I mean, this is quite a different type of experiment too.
Yeah, actually, I've been advocating MMX in space before I started to recently advocate for repeating Brillet-Hall, because I thought at the time that Brillet-Hall's spurious signal was just buried in noise, and tough to that easily could just be noise, and that you needed a faster velocity with respect to this ECI to make a decent measurement. And the best way to do that would be at least putting it into low Earth orbit, where the ether wind with respect to the spacecraft or the International Space Station would be the orbital speed of the orbit, which is like around 7,000 meters per second instead of 350 meters per second. And the effect, since it's a second order effect, is proportional to v squared over c squared, would be the square of that velocity difference. So it'd be much easier to detect. So I agree, yeah.
Yes, so perhaps your own proposals could be merged, because if I say it correctly, you're suggesting that we do an MMX type experiment in outer space or in low Earth orbit in order to get rid of these terrestrial effects. But
well,
if
it's not only that,
we might as well use
a higher, even more important, it's to have a higher velocity to test against.
Okay, so if we do that, we might as well use counter-propagating laser ettalons rather than the 1880 type mirrors.
Yeah,
We might as well
actually,
do a BH type experiment.
absolutely. And
Okay.
others have proposed it too, but to get it past a committee to approve it has been completely shut down. I think Zapfi,
Carl Zapfi.
yeah, Harry Ricker mentions him as making some headway in that, and then eventually just got ghosted. But because he proposed it to NASA, but and even in 1986, Zimopoulos and Theocritus, two physicists at King's College in London, were able to publish in Physical Review Letters a proposal to do it in space, just because it was a different reference frame, not necessarily that the velocity would make a difference, but they got published. But just the fact that this signal, maybe 50 sigma in terms of how strong it was, that Brillet-Hall supposedly found, should be a lot cheaper to look for in a ground-based experiment. That's why I'm switching my
if you wanted to do a definitive experiment, to see if you wish to perform a definitive experiment to establish whether a Brillet-Hall experiment, terrestrially based, would show up the rotation of the Earth at the location where the experiment is done, one would have to do that. Now, if one got a positive result, I dare say the mainstream might find some other excuses to dismiss it. But the problem is that if you did this thing in space and you got this high speed, they might say, well, no, you still can't do it on Earth and you won't get an experiment. And they'll still think that the original Brillet-Hall experiment did not show this up. But I think there's an increasing level of opinion that the original 1979 experiment actually did show this up, unless these calculations done by Aspin and Hayden are erroneous. Well, it would be quite coincidental that they give exactly this that speed of rotation of the Earth in Colorado.
Yeah, the problem with that is that if I'm right, or if Brilliant, or if Sue and Hayden were right, the actual speed would be impossible to detect by eye. They were talking about a 40th of a friendship was the best they could measure. The original
by the old style experiment, yes.
Yeah, and the instrument would only perhaps, if you could eliminate any noise sources, generate maybe a 10,000th of a fringe shift, which would be impossible to detect by optical attempts to detect.
Right.
Because of the V squared over C squared effect.
There are two proposals, and I mean, one I think would have to have regard to practicalities and which would be likely to get attention and so on. One could do an experiment in space, which you've been advocating, but one could do an experiment which might be easier, cheaper, perhaps more easy to persuade the authorities to perform on Earth with modern equipment, where perhaps one couldn't, if one got a similar result, one couldn't dismiss it so easily.
Yeah, and then that might be enough of a motivation to try it in space. and even better in interplanetary space, where it should be the full 30,000 kilometers per second flow due to the spacecraft's orbital velocity.
Do you see the former would merely entail
you're in the sun's
persuading some academic
reference frame?
Yeah, persuading some to do the terrestrial-based experiment. I say merely, but relative to the other one, the other one is very big. It means getting NASA involved, or Elon Musk, or some private European body.
That's been my dream.
Yeah, quite so. If one could, dare I say, controversially overcome the prejudice of the main establishment and get maybe some academic institution, research institution, or university.
Well, that's why I'm hoping. I haven't actually published a formal paper about this, but that's what I'm hoping, that somebody will see it and pick up the idea, even if it's not a university lab. But I would think that some people might be curious enough to try it, since you could probably do it for less than you could probably do it for less than 500K.
Okay,
and do it well.
So we've absorbed the first hour. Do you wish to come back and speak for a little more, and then we'll come back again to the discussion, or are you finished and you want to spend the next hour discussing this? It's really up to you.
Well, I could briefly go into.
I see you had a few more slides there, which you didn't maybe show. You've quite a number of slides.
Yeah.
I mean, you could easily speak for another 20 minutes if you wish, and then we could revert to discussion. There are a couple of people in the green room who I could bring in.
I guess I have to admit that there have been other experiments since Brillet-Hall.
Would you like to say a word or two about them? Because many people, including myself, are not necessarily conversant with the details.
Yeah, and they essentially
I'll give you the floor now.
They essentially were motivated by a theory proposed by a physicist named Kostolevsky, who talked about standard model exceptions, or SME as an acronym, that he was predicting at some level of sensitivity would show some kind of Lorentz invariance violation. And that motivated a string of experiments that were done between 2003 and 2021 to essentially test his theory. And they made the same assumption that Brillet-Hall did, that the only valid signal had to be what they called sky fixed. In other words, that it was coming from a motion, essentially a universal preferred reference frame. Essentially, they were looking for a signal related to the CMB dipole. And that just like Brillet-Hall was saying, any signal that did not follow that pattern had to be fake or systematic or spurious, whatever, not a real signal. And they improved the sensitivity over Brillet-Hall, but they at least didn't report any signal like Brillet-Hall had reported as spurious. But they did the same kind of sidereal averaging, where they by that kind of using that kind of averaging, averaging the signal direction over a sidereal day would, by construction, make it zero. So I'm still trying to understand their pipeline, essentially, which they don't describe in detail, as to whether there was any Brillet-Hall type signal in their raw data. But it's possible that they didn't see it, and that is a question that could be a refutation of my whole idea. I have to admit. So that's a negative that is just cropped up as I was trying to prepare for this, and trying to use AI to assist me in analyzing these other experiments. There are about 5 of them that could be significant. Initially in 2003 timeframe, or even 2000, their experiments did not rotate on a table, which would make them totally blind or insensitive to a signal that was always due to the Earth's rotation and due east. They even used the LIGO or LIGO, I don't know how to pronounce it, device to supposedly look for a signal, but obviously it can't rotate, so it would never see an Earth rotation signal. But then in 2005, I guess there were several experiments where they did use a rotating table, in particular this one by Herman, I forgot his first name, actually. Herman was his last name. He was the prime author. And he claimed he didn't find anything that was related to Brillet-Hall's signals. So I can't tell for sure whether he's talking about a sidereal average signal, which I'm saying is not the way to test an Earth rotation signal with respect to the ECI. That it should come out zero if you average your data that way. So I have to try to look at that in more detail. It's a puzzle for me, at least. But the point that AI was trying to make was that none of these other experiments, ISIL and Nagel and Antonia Chang in 2021, were looking for this kind of signal. They were looking for a sidereal average signal. So it hasn't really been tested properly, which is why I am advocating that it be redone and specifically look for the signal that Brillet-Hall detected, and try to prove that any possible systematics are not contributing to a signal if you can see it. So my design, which some of these slides talk about, proposed kind of general design, tries to give it a general outline on how to design a follow or a repeat of that experiment. And one of the important things to do would be to, if you do find it at some latitude, would be to then move the same device, make it portable, so you could move it, drive it even on the back of a truck, perhaps, to other locations, Alaska, Key West, whatever, and try to see if the signal follows that coast latitude, maybe coast squared latitude amplitude, which would make it much harder to dismiss as a systematic. And particularly if you can prove that it has a constant phase, and that phase points due east.
Yes, that would be a most interesting series of experiments, Jim.
Right.
One thing that occurred to me that I don't see it in the comments here, but it's 47 years since the original experiment. I don't know if you know whether these researchers are deceased or still around, but some of the experiments done, or analyses rather, about this spurious signal were probably done in the 90s.
Aspen, and there was another guy, Klauber, who also tried to
he published
explain it as
so I'm wondering, was there any comeback from Brillet and Hall on that analysis?
I'm not aware of it.
Yeah.
Although Hall, Howard Hayden actually did communicate with John Hall, who, by the way, won a Nobel Prize in several years after, I think it was 2005 or something for metrology, exactly this kind of very precise frequency measurement that was required to that was innovative and bleeding edge back in 1979 when they did their experiment. So the other point, another point, that these other SME seeking experiments were not exactly the same. A lot of them used crossed dual cavities. 3 of them used microwaves with a solid cavity, a solid crystal, instead of a vacuum between 2 mirrors, which is the only way to really detect a difference in effective velocity of light, which who knows how the difference in velocity of light would respond to microwaves being sent through a solid cavity, a crystal cavity, so I kind of wonder whether those experiments should count as refutation, but just wanted to make that slight point.
But if anybody's interested in the details, it's quite fascinating. They used helium neon laser, but there's also a stabilization one, which I think is methane.
You need a reference frequency. Essentially, you're trying to say that the resonant frequency of the cavity is a function of the speed of light through that cavity back and forth between 2 mirrors. And you're trying
they're getting all these results by heterodyning signals. Right. So in a way, what many of us are saying possibly is that the experiment is very impressive. They've gone to great lengths to eradicate any possible source of error and perform a very highly stabilized system. But yet the results seem quite dismissive of real
entities. According to their theories, which they imposed on the experiments, they were doing valid experiments. It's just that I'm challenging the validity of their theories, essentially.
Yes. and to boot, maybe challenging their objectiveness, because they can have an incorrect theory, but that shouldn't bias them into twisting around results of an experiment, if indeed that's what they did. They should be totally
and it's kind of
open-minded.
circular too. I mean, it's all based on the idea that special relativity is absolutely correct, and that's that's what leads to this assumption that any real signal has to be sky fixed, has to point to a direction in the sky, and has to be
Yes.
averaged sidereally. So that, in a sense, is a bias, and it's a bias that assumes a preferred reference frame. So it's weird.
You mean a general
CMB
ECI?
Yeah. The CMB dipole is flow through a universal reference frame.
The microwave. I was looking at a program on the universe, so-called, by Brian Cox, just recently, by the way. And what he said, I think I'm paraphrasing him correctly, he said that until very recently, we extrapolated the expansion of the universe back and got a Big Bang. And it was invalid to talk about what was there before the Big Bang, because there was no time and no space. But in quite recently, we've changed that view. And he said now the current view is that you may talk about what happened before the Big Bang. And what happened before the Big Bang was that there were waves. There were waves of energy. Sorry, just a telephone call. I just got rid of there. So that's quite a departure from what we've been told up to now. So these things are changing, but they're changing in the most weird ways. They're not moving, what we might consider more rational explanations. There were a couple of other points here, by the way. I'm just trying to retrieve them now, which were related, but not exactly, maybe following on from what you said. There was something about the transverse Doppler effect. I don't know if you have any views about that. That maybe it's not real. In fact, it was by Professor.
Yeah, I haven't really analyzed that.
Okay. He just gave a reference, I think, to one of the papers. Let me see anything else there. Really, a lot of discussion. Yeah, this is it actually. Yeah. I think this work is in the absence of the relatively transverse Doppler effect at microwave frequencies. Yeah.
Oh, hi, Hallam.
Yeah, he's here. So, because we haven't been on for some weeks, so we're a bit out of touch with all our regular people.
Glad you tuned in.
Yes.
Actually, I have heard of it. And I'm aware that Dr. Thim has some heterodox views about relativity, but I haven't really investigated it to any depth.
There's some discussion also about an open Apollonian theory of everything. I don't know what that's all about. They're just published May 17th, bring up to date. 2020.
No, I'm not familiar with that either.
Yeah, okay. Well, one good thing is these seminars we have, they spur people on to think about other peripheral things, which is most useful as well. Here's another thing. Walter Cruttenden's work here. In a nutshell, the inertial gravitational frame of our whole solar system precesses relative to distant stars. That would be the local ether then.
Is that the Weniger of the electric universe?
I guess it might be. That I'm not sure. Maybe Shockwave can tell us that. It probably is.
I'm not sure if it's the same spelling.
Yeah, and Kev Con has been making a few comments here. I just repeat that we'd be happy to have an offer of a presentation defending both theories of relativity, or one of the theories of relativity, as being essentially a correct description. We'd be happy to get that. Oh yes, I have that. Kev Con.
Cool. Hey, say hello to Sam.
What's a semi? You know more than I do. I don't know what this is. He said something about who's Sema?
Sorry. He has a lot of see the pattern. Have you ever seen his videos? I forget.
Sounds familiar, but yeah. I think he's a little critical, is he?
Sorry.
Is he a little critical of the accepted views?
He's challenging a lot of standard cosmology model, and he's even had a series of videos on the Aether. Garth Samuels, I think.
Okay.
Right.
And Renshaw, I think he has some videos as well, but I don't know if it's some contradiction. He said, I've worked a lot of this moth, no ether or Einstein miracle errors. I'm not quite sure what is it there. He has a bit about Doppler as well, it says. Yeah, okay. Well,
I actually met Kurt at CNPS conference 2016.
Okay, 10 years ago. Okay. Well, I'm just wondering if we could maybe see, does anybody else in the green room wish to come in, or indeed James Keane wish to come back? I see we have we have James Aratoon here, actually. I don't see any video or mic, but he's logged in. If you'd like to come in, that's possible. Actually, Vladimir Taylor was here, but he's gone. I don't know if James Keane wants to come back. If we finished his discussion, I don't know if any further comments have been put back in the private chat. I might just because he's basically saying he gets the impression that the crucial questions are not being asked. Well, I mean, James, may I ask you, are you convinced that it would be worth the candle to do some of these experiments? Maybe in the first instance, a repeat of this 1979 experiment with modern equipment, and maybe in the second instance, an orbital one.
Yeah, well, it makes sense to me that we gather as much data as possible. I think that there's many ways to skin this cat about whether there is an ether. As you may know, in my work in binary mechanics, equations 1 through 6 actually define the ether mathematically. And as far as I know, that is the best definition of ether that exists in physics today, because the equations of binary mechanics have been able to derive the measured value for the speed of light. And so that's an achievement which no other laboratory or theory has accomplished except binary mechanics. So for what it's worth, binary mechanics does assume and in fact define a universal ether. Now, I don't know about this focus on the ECI frame so much. Um, Presumably, the cosmic micron background radiation dipole is more a fixed star, or you might say galactic reference frame, and that's preferable. So I just throw in some comments that may be relevant or not to Jim. I think the tack that Jim is taking is very useful, and it seems to me that don't we have the light transmission being different east to west and west to east pretty much established, for example?
Yes.
That would establish the presence of a medium, would it not?
Oh yeah, that's the Sagnac effect.
Okay.
In a nutshell.
Well, in other words, I'm not sure what the foundation for the debate is, but Jim is really the expert, Jim Marsen here, and apparently more experimentation is required. So I'm just saying, go for it. I'm all in favor of that.
Well, thank you. I think that's what you're saying.
Yeah, that's a compliment. I appreciate the work that you've done and the presentation that you made today. Thank you, sir.
Yeah,
Well,
actually,
thank
maybe
you
a
very
little self-promotion at this point. This other talk that I'm planning to give in August is essentially about dark matter and whether it exists and whether there's a way to explain the anomalous rotation curves of galaxies with a new assumption about the nature of dark matter. Got over 930 views so far.
You've, if I may say so, done a lot of very interesting fundamental work, but you've also used quite advanced AI facilities, Claude or something, and the
Right.
results, I think, not only impressed and surprised me, but impressed and surprised you. Is that a fair comment? So we're looking forward.
I have to be careful though. A lot of people get suspicious when you admit that you used AI.
Yeah, well, I think you didn't generate the whole thing from AI. You use it to assist. By the way, these two gentlemen, James Vinegar and maybe Kurt Renshaw, were proposing that they might come in on the green room if I posted the link. And I apologize, I should have posted the link at the beginning of the talk. I plain forgot that. So let's see. Does another James?
Yep, another James.
You're very welcome. Yes, I'll call you James W. Have you any comment you'd like to make about what Jim has been talking about today, or you want to question him further or make any proposal, James?
Well, the one thing, like, if you know, like Newton's idea of gravity, that really was like an ether, really all this subatomic particles. But one of the ideas from that theory was that, you know how rotational coupling works in those pushing gravity ideas. What that would mean is that we shouldn't be looking for rotation in that frame, because the whole frame, in other words, is rotating with us, kind of. You familiar with the pushing gravity?
Yeah, I've
Yeah,
a little bit about it.
Is it Lesage type ideas?
Yeah, exactly. I read that book recently. There's like Pushing Gravity by Matthews. He just put all these different people's ideas together over time, like to show that idea is not dead. And I think that's the key, though, to understanding. You know, if you get that down first, then you see why we shouldn't be looking for rotation compared to like a fixed, background.
Yeah, I just have a different outlook, I guess. I think.
See, this is where, like, I'm not. I just had a huge amount of time to read. I'm not somebody that I don't have any original ideas. But what I've been doing, I've been following Gareth of See the Pattern. I was in the Electric Universe conference, and I also went to Walter Cruttenden's conference on precession and ancient knowledge, and I tune in here all the time. I starting to see pieces that go together that people haven't put together yet. Like when I mentioned Walter Cruttenden, all his scientific claim to fame, he was looking at some ancient ideas on yuga cycles, but for like purposes here, he shows that Earth is not in fact precessing relative to other solar system objects. It clearly is compared to stars. And this whole time we've been going on Newton's idea that it's due to gravitational tugs of the sun and moon. But if you look at from a scientific point of view, my background was mainstream astronomy. And sure enough, the precession isn't calculated based on anything to do with masses. It's just by a formula that says we know what precession is and how fast it's speeding up. Okay, I don't want to get off track here with that. But the key takeaway is he showed that, in fact, yes, the Earth is not precessing in that 25 or 6,000 year period relative to anything in the solar system. And the sleight of hand that mainstream astronomers do as they use the solar system frame, the tropical frame, when it's convenient, and the sidereal frame, when you're looking at things outside, and no one put two and two together that the whole local frame rotates in. That means not just the objects in the solar system, but the orbits and everything. And what Walter did come to in his work is that means the whole inertial frame is not fixed to distant stars. It rotates. And then if you look at experiments where like pendulum experiments, everything they do, they haven't been done accurately enough to see that, yes, the whole inertial frame isn't fixed to distant stars. It all precesses in that time period. Now, he tried to explain it as gravitationally, like our solar system isn't a binary, but that doesn't work. For example, the plane of the Earth and Moon's orbit doesn't spiral as we orbit the sun. It stays fixed. So that's where he didn't know the electric universe ideas. And once you see that the double helix nebula is spiraling in about 10,000 years, that makes sense with the electric universe ideas, that this whole, in other words, if you're trying to detect an ether that's evidence that it does exist, and it does. Our local does rotate compared to distant stars. There's no getting around that for our whole inertial frame to precess.
Well, yes, you seem to be encapsulating some idea of some joint movement, perhaps the solar system. And I'm wondering, would that include things like nutation?
Yeah, well, see, once you get that, if you realize all these ideas we have, like we start with the idea of precession that we learned from Newton, right? That Earth precesses like a spinning top. And then we get all those secondary things like changes in the obliquity angle, but that's measuring from that's assuming the ecliptic frame was the right reference frame in the first place. But if that is actually moving, then you see that those other things are side effects, like
Are you questioning Newton essentially?
What's that?
Are you
They
questioning
possibly are.
Newton's laws?
One more time?
Are you questioning Newton gravitational law?
Yeah, that's if you only get one thing out of Walter's book, it's that theory is clearly wrong, and it's not used in. If you look at the actual astronomers, how they predict precession, they say it's caused by gravitational tugs on the sun and the Earth. And when I learned in school, I went graduated in '84 with a degree in physics, and they were still teaching the idea that it was gravitational tugs on a spherical Earth. That later patchwork that it was no oblate. That was patchwork. It still doesn't work though. And precession is predicted. Look up Newcomb's formula. It doesn't make sense. What we do know from observations is that the rate of precession has been increasing for at least 120 years. There's nothing in gravitational forces that would explain that. As a matter of fact, the moon is slowly receding, from not significantly, but there's no reason that
I did ask James whether you included nutation in your suggestion that it wasn't due to.
See, again, if you have from Newton's idea, we get the reference frame, right? That it's the plane of the sun and moon's orbit that caused precession. But if you realize the whole solar system is precessing, then you're measuring ideas of the obliquity angle and nutation. Those are using the wrong reference frame.
Okay, well, look, you've raised a number of interesting points, which would require us to go into this in a little more detail. And actually, I'd invite you to consider perhaps if you're interested in dropping us a line about giving a further presentation yourself on this subject, because while it is interesting, it's not, totally germane to the details of the Brillet-Hall experiment. But we'd be happy to have a presentation from you on this, James, at a later stage.
Okay. Yes. Okay.
Okay. Well, thank you very much for your contribution.
Yeah. Sorry for the long interruption, but
no, information is always good.
Great to see you, though.
Yeah.
Say hello to Gareth for me, because I've been trying to get in touch with him.
Oh yeah,
okay.
Yeah. I'm going to be back with him too. I dropped off to do some independent stuff, but yeah, he and I started together back in 2006. We were doing a lot of videos in the gravity series and the precession series there. He was noticed the same thing I was pointing out, and he went a little bit deep in one of his early videos.
Well, thank you, James, for coming into the green room once I posted the link. They said both you and perhaps Kurt would come in. I don't see Kurt. So I'll bring you down for the moment. If you wish to come back before we finish soon, just raise your hand. Thank you. Okay. So does anybody else in the green room wish to come back? Now, at the moment, we have James. James, I'm going to bring you in. I think you raised your hand simultaneously. So would you like to give your own take on what Jim has been saying and what his proposals are? Do you think there's any benefit? You're breaking up a bit there, James.
Is it? Oh, is it work now? Yeah.
Yeah, that's better.
I don't know where my video went.
Your video's up now.
I wanted to ask the effect of this experiment. Is it somehow due to the actual, because it's rotating, how to explain it? You mentioned the Sagnac experiment. Is it due to the fact that it's like a Sagnac effect, where it's by the experiment rotating, it's creating a sort of pseudo area at the center of the experiment? Because the Sagnac experiment is just a light beams around a contained area, and that's why you get the Sagnac experiment. And the Michelson-Morley experiment gets rid of that area. But if you move the experiment, do you pseudo create an area? Have you ever thought of that? I haven't done the maths whether there is something, because you're not actually measuring the same still experiment. So there could be some pseudo area created, and that experiment would be obviously depend on the velocity of rotation, if there was one created. I mean,
area.
Contained area within the center of the experiment.
Yeah, actually, that's what I consider to be a misunderstanding of the Sagnac experiment. What I tried to explain before about the rock in the pond is that the Sagnac effect is not per se a rotation phenomenon. It happens that if you take a circle and calculate the propagation of light around the perimeter of the circle, that the formula for the Sagnac effect happens to also look like an area. So it's an equivalence of the formula. It's not the effect. The effect is the change of path length. It just happens to look like it's the area, and it doesn't depend on rotation. Like I showed with the pond, it's just the change of path length as the wave propagates to the receiver. Straight line or around a perimeter or from satellite to satellite. It's not, rotation is just a way of generating a change in path length. But special relativity can't account for that. Special relativity and even Lorentz relativity is only a second order transform.
Yeah,
it can't account for a first order phenomenon, which is what the simple Sagnac effect is. And I actually forgot to mention that this actual Sagnac effect is a series. It's the first order V over C is the first component, and then V squared over C squared divided by 2 is the second component, and it continues as a series. But even the second order piece of it is very difficult to detect for when your C is the speed of light. The thing is that when you take a pair of mirrors, with a fixed length between them, and you reflect the light, if there's a velocity, if they're moving with respect to a medium, the reflection cancels the first order effect, but the second order effect is still there. And that's what Michelson and Morley were trying to measure.
Yeah.
And what Brillet-Hall was trying to measure, essentially, it's two mirrors, essentially, the fixed length apart, and you bounce the light beam between them and look for a resonance with the cavity. But and that's kind of the nutshell of my argument, that the Michelson-Morley is essentially the second order component of the Sagnac effect. Does that make any sense?
So you think
I
the
would
effect
have
is
said something
external?
similar myself.
Sorry?
Well, I don't know if this helps, but I would have said, if you look at the formulae for the Sagnac effect, well, if you have a sort of circular system and you just substitute the area pi r squared into the formula, you get the general Sagnac effect. But actually, more specifically, it seems to depend on the actual path length rather than the projected area. It's just a mathematical artifice, I would say.
An equivalence.
So it's a totally separate effect, yes. Yeah.
And in fact, you have to do a line integral for a general path, by the way.
But you're right, it's all connected with the same effect. And this seems to be, if I may say so, the bane of the mainstream Sagnac.
Yeah, well, and there are arguments, they've been floating around, since the day Sagnac did his experiment, and even before, and trying to explain it in the context of relativity. You have to stand on your head and do a twirl or something. And then somebody comes along and invalidates the explanation. But it's their escape hatch that it's not an inertial. That's their.
Just one
it doesn't apply.
question.
But it
have
should.
You done a search? I'm sorry. Have you done a search for institutions which have a Michelson-Morley type experiment sensitive enough and perhaps portable enough to repeat your experiment without actually, purchasing experiment to rent it with the user, to raise the money to rent it with the expertise to use it or to operate it.
Well, you're talking about for my proposal to repeat it?
Yes.
Yeah, actually, the technology has advanced quite a bit since '79 in terms of doing these kinds of measurements, and a well-equipped university lab even probably has most of the components they need already. So if anybody is out there listening, do it.
Because it would be, a week's work and a student project, even.
Yeah, even it should be a lot cheaper and easier than when Brillet-Hall did it.
Yeah.
But the problem might be not only the money, but the implication that the university or the general experimenters were incompetent and they were not able to do an objective experiment, and you would need an outsider such as whoever would volunteer to do this. But it's an interesting idea all the same. So if you get
incompetent, they would just, perhaps, if anything, your mind is just set along rails, and sometimes it's hard to come off them. So from what the analysis presented, they seem to recognize there was something there, but then they decided that it was it was not worthy of further pursuit. But that might be just that they're on the certain rails, or it might be that it wasn't a part of the noise signature. Who knows? I don't know. So
the thing is a bit ambitious. I rather like what Jim said earlier. You may be doing a mobile one and plotting the results against maybe the latitude of the location or the speed of the location.
That would be great.
Number. That would be interesting.
Yeah, well, it would be ideal on the American continent because you can travel by road over quite even huge positive and negative side of the equator. So although this,
yes, you mentioned that earlier, Jim. Okay, well, thanks very much, James. Good to see you, and I'll remove you now. Thank you. So I think we've exhausted. I'm just pointing out in the chat there that the generic link to the green room is live.naturalphilosophy.org. Now that should go into any current correct specific link for the week, but it doesn't always. And I think one of the main culprits for that is one's own computer may have remembered the previous one. So if you click in that, it goes to the previous one. So that's why some people need the specific link today, which I've posted in the green room. And I should have done that at the beginning. Anyway. So Just before I give you the opportunity of summarizing what you've said and maybe your proposals for the future, I'll just see have any comments come in the last while. I thought that the Facebook, I got an error message saying that you perhaps might lose your Facebook connection. This is the main natural CNPS link, and I feared that was so. Maybe David the Hilser has to do something to make sure that doesn't happen. But he's actually sent in a message himself on Facebook, so maybe that'll be all right. But I think the people that participated through the general media were all participating through YouTube today. Okay, so I think we've captured everything. But if Kurt Renshaw wants to get in touch with us with any specific proposals, or maybe to talk to us, that would be all.
Yeah, maybe
Quite welcome.
maybe mention the local ether model as motivation for this. That there's always a question of if the ECI is non-rotating around the Earth, where does it end? You can't.
Oh, right.
You can't extend forever, because some people get confused because it's a coordinate system, which obviously does extend forever. The coordinate system, but the actual halo has a limit in terms of where the it's more like a halo around the Earth that doesn't rotate with the Earth.
Well, if there are various layers of local ether, and I think it would make sense to say that these would be not discrete, there'd be a continuity. So the local ether would merge into the next one. Well, if you sort of model that, well, some of the results that I've got anyway would be perhaps counterintuitive, that something originating from a very distant ether would maintain its. We've talked about this before. You talk about things like aberration taking place at the local ether level, and I talk about, well, I think it's the same. We're talking about the same thing. I talk about something originating, starlight originating in the ether around that star, maintaining its properties, because there's effectively a cancellation between the relative speeds of rotation of the different ethers and the refraction that would be a consequence of that.
Right. Actually, Beckman had the best explanation that I've seen about it. Peter Beckman's Einstein plus 2.
Yeah. Yes, you mentioned that to me before. Yeah.
Yeah.
And I think what I did would be consistent with that. It's maybe just another way of looking at it.
Right.
Okay.
So this hierarchy continues all the way up into the Milky Way, and then beyond into the local Virgo cluster, and
right.
Into superclusters.
But it would be interesting maybe to say when the effect of the local ether would have diminished to a very small quantity. For example, it might have diminished to 1/e of its value at the surface of the Earth. They talk about.
I think that may actually, in fact, that's kind of what my other paper is about for galaxies. That there is non-baryonic matter associated with baryonic matter that fades as a 1/e at the outskirts of the galaxy.
Okay.
But I'll try to go into that more next time, I guess.
Oh, okay, well, that'd be interesting. So what I'm going to do, I see Cornelis has just logged in, but to get him sorted out, he's not even connected yet. I think it's probably a bit too late now. He could obviously pop in any questions if he wishes, either now or at a later stage. So what I'm going to do, if this is agreeable with you, Jim, is I'm going to hand the floor over to you for as long as you want. You could take a minute, or you could take 10 minutes. Just to summarize what you've done, what you're proposing, maybe in the light of any questions that have come up, and what you're proposing for the future. And then I'll come back and officially close the meeting. So I'm going to hand over to you again, uninterrupted.
Okay, so my paradigm essentially is the same that follows the local ether model of Professor Ching-Chuan Su. I guess it would be good if we could post the link to his book for anyone that's interested. But essentially, it says that the preferred reference frame for electromagnetic potential is at rest with the gravitational potential field around any celestial body. So there is no universal ether in the sense that it's the same everywhere for everything. That it is variable. It has a variable density even that can affect the speed of light. I guess those are, that's the deeper reason for my challenging the current paradigms, special relativity in particular, and that the experiment that essentially led to special relativity, I claim it is the Michelson-Morley experiment, and that even though some of it have said, well, Einstein never cited it in his 1905 paper. Just because he didn't cite it by name doesn't mean that he didn't make use of it, because the very first few paragraphs of his paper, he referred to the two-way speed of light being the same for everyone, which is the conclusion that you're left with if the Michelson-Morley null was and is null to infinite precision. According to this local ether model, where it's carried with the Earth or any celestial body, but doesn't rotate with the celestial body, like the gravitational potential. The gravitational potential field is not considered to, around the Earth, is not considered to rotate with it, as far as I know. At least I don't think it does anyway. And that is in effect what I consider to be the preferred reference frame that the original Michelson-Morley experiment sought. And again, what I tried to say was that the fact that they were looking for a universal reference frame was what led physics astray, totally astray, essentially. That assumption, and that the null they experienced wasn't because it was really infinitely null. It was because the signal that I think is the real one, the velocity, was too low for them to detect with their 1887 instruments, or any of the instruments that were used up until Brillet-Hall, that the velocity of the Earth's of the lab with respect to the substrate is actually maybe a more modern term. Propagation substrate was or is much lower than what was assumed and what is still assumed by this CMB dipole finding. So the fact that there is a second order component to the Sagnac effect, and the fact that GPS and several other Earth rotation phenomena like the ring laser in Christchurch and outside of Berlin detect the Earth's rotation to extreme precision every hour of the day. And the one in Christchurch was at one time inside a mountain, and it still worked. That's in New Zealand, by the way. Meter scale ring laser. And other Earth rotation experiments or measurements, like the Michelson-Gale experiment in 1927 outside of Chicago with a kilometer square interferometer that did detect the Earth's rotation as a first order phenomenon. All point to, and the operation, like I was saying before, the operation of the GPS system effectively depends on, or at least works best if you assume that ECI, the non-rotating halo of effectively Aether, that is, at least in my estimation, the preferred reference frame that special relativity says cannot exist. So that's my challenge, that the second order residual of the Earth's rotation that's detected by the first order by GPS Sagnac correction was detected by the 1979 Brillet-Hall experiment, which is the first one that was sensitive enough to detect a relative velocity of the lab that was only 355 meters per second instead of 300,000 meters per second, was real. And that's my that's my choice, and I'm sticking to it, or something like that. Anyway, so I like was also said before, that the fact that that a better experiment would be to do it on the International Space Station, where you'd have all the backup equipment, communications, vacuum, whatever, no gravity, shielded from sunlight, heating, easy to make it rotate without being vibrated, would be, and most importantly, a faster velocity with respect to the ECI to make it easier to detect a signal would be the best thing to do, but due to the fact that mainstream is so convinced that special relativity is settled science, would predict no result and therefore would not approve such an experiment. Probably that Brillet-Hall would be a lot cheaper to do. So that's why I switched from advocating doing it in space to first trying it with better equipment on the ground. So that's my story, and I'm sticking to it. Right.
Okay.
So thank you for the time. I appreciate.
And thank you very much. And I'll bring it down just to close the meeting. We've run out of time. Thank you very much. So on behalf of the CNPS, and indeed on all your behalves, I'd like to thank Jim very much for having come today and having prepared all this information, background information for us, because many of us are not familiar with the details of this seminal experiment, which was carried out almost 50 years ago now. And unfortunately, what is conceived by many of us to have been a dismissal of a very important result from the experiment. And indeed, Jim's proposals to carry on maybe in outer space or in more specifically now to perform this equipment with updated perform this experiment with updated equipment is very, very important. And I'd say just keep banging on the door. It's bound to open. So I'm hoping that this session today and the recording of it will, even in a small way, help to propagate this idea that maybe this is something that is worth doing. And in fact, we'd be quite negligent in the scientific community if we just dismiss this and said, oh, it's all been done, we don't need to look at it again. So I'd like to thank Jim very much for that. And indeed, he's kind enough to have agreed to come back to us the next time, I think in 2 weeks' time, and talk to us about another area he's been studying, which is the sort of parent galactic motions, which might appear to be in contradiction to Newton's laws, which otherwise are quite acceptable. So we look forward to that. Actually, if I may just boost a little myself, I've been looking at this as well in another way. A lot of our ideas are actually complementary. We tend to look at similar problems in similar ways. So I'm hoping to maybe speak about this subject or a related subject about apparent galactic images and so on at tomorrow's session on cosmology, which is convened by Harry Ricker. So thank you very much for all that, and we'll keep the fires burning. Hopefully, just keep an eye on the announcements. James Keane, is there any evidence for a local ether? Well, yes, I think we're trying to indicate that. My conception would be an ether, and Jim talked about the gravitational effects, and perhaps could be electromagnetic effects, which would determine what the local ether does. I think one doesn't have to rush into conceiving of an ether, if indeed there is an ether, that's universal and is the universal frame of reference. That's the old 19th century view, and it might be quite easy to debunk that, but that doesn't debunk the establishment of an ether, which actually we know there is something there which conducts electromagnetic radiation, for one thing, that we know of its properties. So for bringing all these ideas to us today, I'd like to thank Jim very much. And actually, as I've said on a previous occasion, if I've appeared to have agreed very much with Jim and not to have put a couple of hard questions to him, that is probably because a lot of my research, as I say, is complementary to his, and we've reached very similar conclusions. But I do apologize as a convener, as a host for these meetings, if I have appeared to give them an easy ride and not ask some hard questions. If there are any harder questions which you wish to pose, please do write into us and we'll deal with them. So I must end the meeting now, and I'll wish you all, wherever you are, a very good day. Thank you very much for attending today, and we hope to see you very soon again at our next session. Goodbye.